This question is from GATE 2012 Mechanical Engineering paper, question number 39. In a DC arc welding operation, the voltage arc length characteristic was obtained as V arc equal to 20 plus 5L, where the arc length L was varied between 5 mm and 7 mm. Here, V arc denotes the arc voltage in volts. The arc current was varied from 400 ampere to 500 ampere. Assuming linear power source characteristic, the open circuit voltage and short circuit current for the welding operation are. Let's find out. Let's denote open circuit voltage with the short form OCV and short circuit current with SCC. The relationship of characteristic arc length is given with the voltage arc, which is V arc equal to 20 plus 5L, and L is being varied from 5 mm to 7 mm. So we can calculate the variation in arc voltage also. So V arc will be equal to 20 plus 5 into 5. This gives us 45 volts. And when we take the characteristic length as 7 mm, we get 20 plus 5 into 7, which is 35 plus 20, 55 volt. We have the variation of arc voltage as 45 to 55 volts. Variation between arc current is also given. VI arc, it's 400 to 500 ampere. Now, the relationship between OCV and SCC is written as arc voltage V arc by OCV plus arc current I arc by SCC is equal to 1. We can use the combination of arc voltage and arc current to write down each of the equations. So by using 45 voltage and 500 ampere current, when arc voltage is minimum, current has to be maximum. So substituting it here, we get 45 by OCV plus 500 by SCC equal to 1. This is equation 1, and 55 by OCV plus 400 by SCC equal to 1. This is equation 2. OCV and SCC have unique values for a characteristic arc, and therefore equation 1 and equation 2 are simultaneous equations. In order to solve them, we will eliminate the term containing SCC first and calculate OCV. Subsequently, use OCV to find out SCC. So multiplying equation 1 with 4 and equation 2 with 5 and then subtracting the resulting equations. So we have the first equation results into 180 by OCV plus 2000 by SCC equal to 4, and the second equation results into 275 by OCV plus 2000 by SCC equal to 5. Subtracting this equation from the first one, we have 275 by OCV, the second term 2000 by SCC minus 2000 by SCC gives us 0, minus 180 by OCV, this is the left hand side, equal to 5 minus 4, that is 1. Now from here we get OCV equal to 275 minus 180, that is nothing but 95 volt. Using value of OCV, putting it in any one of the equations, we can get SCC value. So resulting value of short circuit current is equal to, if we put OCV 95 here, we get 45 by 95. And to calculate SCC, we'll get 1 minus 45 by 95 going into the division with 500. So we have SCC equal to 500 upon 1 minus 45 by 95. This gives us the value of short circuit current as 950 and the unit is ampere. So we get OCV to be 95 volt and short circuit current SCC to be 950 ampere. Let's go back and mark the correct option. 95 volt and 950 ampere is given in option C. Option C is the correct one. To learn more about welding power sources, you can refer to the NPTEL video Lecture 5 Welding Power Source 1. It's from the course Fundamental of Welding Science Technology. The course is by Dr. Pankaj Biswas from IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.